today we're going to be covering your SQL database, how to scale it, all replica sets, etc. Going through basically what I did at Hypixel, going from day one to where they were at their peak at 260,000 concurrent players. Let's start day one. What do we have? We've got a game server, 50 concurrent users, speaks right to a Postgres, rewrite. Now, what possible problems could we have here? Our game server saturates one CPU. Minecraft server software is single threaded. So we hit 150 concurrent players and all of a sudden this one CPU is just getting thrashed. One CPU core. What are our options? We can hard cap the amount of players per server, but this doesn't let us grow it. We can vertical scale the box, so buy a CPU with a faster single clock speed, or we can split into specialized servers behind a proxy. Obviously, that's the one that we've picked. So now we start having a proxy in front of our servers. So what happens is the player joins, they connect to the proxy, and on the back end, we're actually switching their connections to the different game JVMs, but on their client, they're just always connected to this one proxy. So they will see a loading screen, they will get disconnected, etc. And everything runs to this single Postgres. Problem arises. Our P99 query latency goes from 2 milliseconds to 400 milliseconds with the common SQL error, connection pool saturated. So what happens in your Postgres is that you've got a certain amount of connections in your connection pool. And when you start sending from too many JVMs or too many different clients with different pools, you start oversaturating how big this connection pool is. The solutions, we could drop a PG bounce in front, and I'll describe what that is a little later. We could have a bigger DB box, so obviously we just improve the hardware, but eventually that does hit a wall. Or we could have an in-memory write buffer per server, so we batch things locally on the actual game servers, and then every 5 seconds we send it out to try to not actually kill the connection pool. But this means that if your server crashes in those 5 seconds, you've lost 5 seconds worth of data. So kind of a swap pick. Or we could put a shared Redis in front of the DB. Now, this is one of the things that we're going to talk about as a kind of DB smell, is that this is sort of doing too much to serve. So this is a huge architectural change, and this Redis will be something for us to maintain that's separate from the Postgres that we simply don't need now. So we went with the PG bouncer. So what PG bouncer is that all of your game servers talk straight to your PG bouncer, which has, let's say, theoretically infinite amount of connection pools. So they'll just give away pools to all your game servers, and on the back end it multiplexes, which basically means reduces many to 10 to Postgres so that the Postgres doesn't get overloaded in terms of connections. So PG Bouncer has all 10 pools.
Yes, quick question. Maybe in too much of the details, but do you know how that works? Is it essentially just a batches writes and then we'll do a single write to a single connection? Is that sort of what it does, or?
Internally it has a ledger. That is going into. So it's sort of batching, and then it waits for things and goes to the connection pool, and it sees what's dependent on each other.
Yep.
PG Bouncer. Now, we have a problem. Every kill, every XP tick, every coin is a synchronous write to the Postgres. We've got 15,000 writes per second. The write-ahead log saturates the NVMe, so the log for the PG Bouncer, since it's a ledger, starts being absolutely shot full now, because it's just all in the NVMe. So, what do we do? Option one, go back to our batch writes per server, flush periodically. We already explained why that's a bad idea. You'll lose all your data if it crashes. We could have an append-only event ledger, Kafka. So talk more about that later. Hint, when I say that means we pick it. Or we could shard the Postgres by play UID now. However, this is a huge operational jump because we don't even have replica reads yet. And also, this one database is across all of our data, and we don't necessarily want to shard all of our data. Sharding is something that you want to do after you've split your database per topic domain, which we'll get into later. We pick, obviously, the event ledger on the Kafka. So this is how that looks. Basically, your Bed Wars server will emit an event that says player X has won a game. And then that goes into Kafka as an event. And then you have a processor, or you have a consumer, which processes every event from your ledger and goes, okay, if this person won this game, that means we need to increment this in the DB. And that talks straight to the PG Bouncer. This is better because it means that your individual game JVMs don't need to worry about, okay, this player won and now I need to go update this stat, and they're all talking to the PG bouncer and they're oversaturating the NVMe. Instead, they can just emit an event, forget about it, and this is also better for decoupling your data to how it's processed. So it goes into the event ledger, that gets consumed by your consumer. It's also good because that means your consumer is sort of your source of truth for where your writes are going in terms of linking events to what's being written. Problem. So let me just clarify here. It's important to notice whenever you've got a slowdown in your DB, is it a write problem or is it a read problem? Because usually they kind of get mixed up into the two, that you just think, oh wow, my DB's slow, without thinking, is my write slow or is it my read architecture that's slow? So here, for example, the writing is extremely quick. The servers are just outputting events and they don't need to care. However, whenever you join a server, they trigger 6 different queries for reads. They get your profile, they get your cosmetics, they get your friends, they get your guilds, they get your stats. What's the solutions? We could have read replicas on Postgres, and this, is good in concept, but this can't really absorb the fact that you're reading a lot. Even if you split it across multiple read replicas, a cache for right now would be cheaper. You've got a global Redis in front of every DB, so you kind of like cache your reads. However, that brings a central bottleneck, and it also means that you have cross-pod latency if you go outside of the network, because everything needs to hit this one pod that you've got running. Another solution is a per pod Redis. So you say 5 game servers have one Redis server. So you group servers into pods, and each pod has its own Redis sidecar. How that would look? Or you could push player data on proxy handoff. So when the proxy routes a player, you ship their blob with them, and the server says, okay, thank you for the data. So basically, you're not even writing to the DB anymore. The proxy is just sending data as you move across. However, this completely couples proxy to data model and removes the niceties of what we had before. We picked the per pod Redis. So how this looks now is that the bedwars is always going to be trying to read from the Redis. And if the Redis can't find it, then it goes all the way to the PG bouncer and reads from the Postgres. However, although this looks nice on paper, there's an obvious problem. If you load data on pod 3, move to pod 1, change your data, move back to pod 3, your pod 3 has old data, because that's not going to go, oh wow, some new information's come into the Postgres, let me go and invalidate my own cache. So that's sort of problematic, especially, we've got ghost inventories and coin balances that are being styled, kind of slop. All we can do is we can have a short tick ls in every key, so Redis knows that after just say 5 minutes or 5 seconds, it can evict the key, and any new requests, read requests, will have to go straight to the DB. We could have that a pub sub invalidation channel, so your stat processor says, hey, player X has changed, and every Redis now knows, okay, if we're going to have a read, then we need to go fetch it straight from the Postgres. Or we could go back, have our one global Redis. However, this, kind of slop. We spoke earlier about why this is not a good solution. Or we could have version stamps, check the news. So every read fetches a version from the primary, and every key's got a version related to it, and it ticks up, kind of like a log sequence number. That means every read will always touch the primary, and it's a little bit painful. So we go with the pub sub invalidation channel. So what happens now is that you publish your event, player X has won a bedwars game, and then your stat processor consumes that. And your stat processor then goes and through a pub sub stands for publish a subscribe channel, and tells the Redis, hey, the next time that you want to read this data, I've just consumed something, that means I've updated its value. So you need to go and fetch it straight from the Postgres. You can't rely on your cache. Now, what problems could we possibly have here? It seems pretty good. We've got the writes are quick, we've got the reads are quick, we have everything working sort of nicely. Wow, our primary Postgres is pegged on input-output operations. So that's just input operations. And what that basically means is that, say we've now got 15,000 writes still happening, at some point, this Postgres is just kind of being absolutely tanked. So what do we do about that? What are our options? We could split by domain, what I was speaking about earlier. Each domain gets its own Postgres, so you separate stats, economy, cosmetics, and social. However, you lose a single Postgres, so you do have to manage more. You could just add read replicas for more replicas for reads. However, what do we have? We've got an input operations problem, which means we got a writing problem. So we don't yet want to start fixing it with reading solutions. We'll get to that later. We could shard by the play you're adding now. However, this, as I said, will shard every table, even tables that don't need it. And also then you have like cross shard joining that occurs, and it's kind of just a huge tank for nothing. Or we could migrate to a distributed SQL. And for important context, Hypixel's completely bare metal. We had no cloud at all. So we did not want to move at all to a distributed SQL. Optimally, we'd be having everything on premise. We pick the split by domain. So now what this ends up looking like is that we have one event bus that reads all the events, and all the processes are looking for specific keys that the event bus has in it. And then the economy will go, okay, that's a write to the economy key. Let me go publish that to the DB. And obviously you can see now everything's sort of started being simplified at the start, but that's the same as what it was previously. So now we've kind of got everything seeming good. So we're writing quicker now. We don't have everything pegged to a single DB, and also the reads are okay. However, when Redis evicts a hot block or pod restarts, everything slams the domain primary. And what that means is because this Redis is cached, let's say the pod just restarted. Every single read is now going to slam one of the primaries on one of our DBs. And one of these per pods store up to 5 JVMs in it. So 5 different servers, and let's say servers are large servers, so we had a differentiation between small and large. They can have 100 players each. 500 players were reading all their data, kind of starting to be slop. And for redundancy, so our reads are okay, our writes are okay. Now we worry about redundancy. Something should probably be done. We have the option, we can have one read replica per domain. So the primary streams to one replica. However, this is sort of a narrow failover path. You don't really have any headroom with just having one. You can have a replica set of 3 per domain. So you have a primary plus 2 replicas, and then you have a hard proxy, which round robins reads, and I'll explain what hard proxy is a little bit later. Or we could just make the cache bigger. Let's throw some RAM at it, let's upscale it. That seems like an amazing choice. Nah, baited you. What we're actually going to be doing is having the replica set of 3 per domain. So what that now looks like is that your processes are going to write to your hard proxy, and your hard proxy knows the difference between a read and a write. So it will always redirect your write straight to the primary. However, if you have a read, what it does is it round robins where you're going to be reading from which replica. So say your first read will go to replica 1, second goes to replica 2, third goes to replica 1, fourth goes to replica 2, etc. Just a simple mod. And it's just going to be switching in between them. So now you've got your reads distributed across multiple databases, and your writes still just go to your primary. So everything seems pretty good so far. Now, we sort of have a problem in our redundancy, is that if something fails, we've got to go get the on-premise team to go on and start changing config settings. And they need to start migrating and that sort of slop. And this is in specific to something that happened in 2020 when we went down for 24 hours. And that was really bad because one of our primary databases went offline and we didn't have any automatic failover, and it was a weekend and no one was there that knew how to do anything. We had people there, but they didn't really understand what happened, and it turned out there were problems in training protocols with the people that we had in the actual data center, and they didn't have anyone that set up our specific stack. So what do? We can have a Patroni plus etcd. So Patroni is an external orchestrator that watches heartbeats, and then etcd holds the lender lease, and it just tells the hard proxy, hey, this is what our primary is. If you're going to write to this guy. Or we could have Stolen, which is similar to Patroni. However, Stolen's kind of not really upgraded anymore. This is sort of, what they used to have back in the day. It's a smaller community and it's not really updated anymore. So we didn't go with Stolen. You can have an application level failover. So, let's start having the clients, so we can have the JVMs, or we have to code custom scripts into the heart proxy, so it kind of sends out a heartbeat for it writes. But this, this means every service needs logic. You've got split brain risk, where say you got one JVM thinks this is the primary, another JVM thinks this is the primary, and then you're not really having your read replicas properly in between them. Or you could buy better hardware. Let's slap some better NVMEs on. No, we don't go with that. We have the Patroni plus etcd. So what this looks like, is that we have our Patroni, which is watching our replicas and our primaries, and it's heartbeating them. And what it does is it talks to the etcd, which is a lender lease, and there's some special sort of configuration within that, but it's just easier to know for now. It tells etcd what the status is, and then etcd tells the heart proxy, and I've got a very simple integration. Hey, who should you be writing to? Who's our primary? And then, we have the heart proxy just sort of listens and it follows the reader. Now, what this also does is when the heart proxy read points, we have a Patroni set up to stonist the down primary. Does anyone know what stonist is? Shoot the other node in the head. That's a technical term. That's a real technical term. So if a database goes down, we shoot it in the head. In the sense that we set statsdb to be our primary, and then we completely wipe the primary and we just completely restart the pod. So we're not worrying about anything like we got stuck transactions, for example, we've got fake data in there, we got problems. We're not trying to sort of like get it back up using logs. We're just going to restart it completely from the start, fresh pod, and then we're just going to clone up the replica. So that's what stonist is.
And is that just for simplicity? Like it's just really complex, like it's your heartbeat's quick enough, you're probably not losing that much data. This is sort of a practicality.
Yeah, the read replicas should be up to date anyways because they're reading from the log. So it'd be better just to have your primary kill and then restart it from scratch. And also, if it's gone down, there could be corrupt data in there. And then say later on it turns into the leader and it starts spreading its corrupt data everywhere. You've just lost all of your DBs. So kill it. Now, we have a little bit of a problem where we've got replica lab. So our stack is kind of starting to look a little crazy. So we're going all the way to our DBs on the right, and by the time the client reads it, say the client wants to read it 50 milliseconds later, the reads actually have old data. It's the pub sub's not being quick enough, and it's kind of just starting to be slop. And at this time, we're rolling out tournament-related features, and historically, it didn't really matter if a Skywars game had a read before a write. It's sort of okay. But now that we've got tournament, more things, and we have a larger player base, it's more important that we don't have any replica layers.
And maybe if you just go back, I just wanted to ask. So at this point, you are trying to do a read. That read will hit the Redis and the cache, and then that cache, if obviously there's been something that's been updated, then needs to go down to the database, but it doesn't necessarily hit the primary. It could hit a replica. So then you're sort of having lots of points in which things could be stale. Is that what's happening?
Yeah, exactly. Because you have your writes go all the way to primary, then your replicas haven't necessarily got them instantly. And we now, we've got the pub sub channels, and Redis is pretty quick, but it's a little painful now. So what can we do? Always read from the primary. Let's get rid of our replicas. Of course not. We're just going to go back to problems that we had earlier. We could have sticky reads. So what happens is after a player writes, we have it noted in our application logic that for the next 5 seconds, read everything from primary. However, this is kind of bad because you've got to start bounding DB logic with the application. And also 5 seconds isn't necessarily the actual upper bound for how long it takes. And that also means you're going to be slamming the DB for 5 seconds. We could have causal tokens /lsn wait. So LSN stands for log sequence number. And what that means is on a write, we return to the application. We return what is the log sequence number that I've processed up to. So say I've processed up to log number 800, and then I'm going to read, and that read depends on log number 810. We got to wait until log number 810 has been processed to now read it. And this is like ridiculously complex client logic now to start implementing. We could have synchronous replication, so writes wait until all the replicas have updated, but that absolutely kills the repl. Or we could have write to cache plus sticky reads. So what that looks like, so now the description is a little confusing, is that now the game JVM will just update the readers immediately. So of course we could have done that initially, but you could see how sort of every step that we've taken along the way was based off of problems that we had and choices that we've made. And it's okay to sort of go back and redesign things a little bit. So what we've decided to do now is that we're just going to write through to the readers and also self-read off of the readers. Now, what are potential problems? Seasonal resets. So you're thinking our reads are quick, our writes are quick, we've got great redundancy. However, we end the season and we now want to write 30 million rows in an hour. Our primary cannot keep up with that because we've only got a single primary that we're writing to. Solutions, we can shard by the hash of the play UID divided by n. So always when you're sharding, you're trying to look at what will split your rows the most evenly, and UIDs are pretty good at that because obviously they're quasi-random rather than doing something like join date, for example. We could shard by game mode, so have a bed wall shard, have a sky wall shard. However, that means one popular mode has one hot shard, and obviously our shards aren't like balancing loads within each other yet. We could have a time partition only, so we could have like a hot partition, a cold partition. However, this means that season end still is all just writing to a hot partition. We could use Vitess or Cetus, which is sharding middleware. However, we've already got enough systems that we're running. We don't really, want to add another one given our scale's not that huge. So what we do is we start sharding. So this sharding means that for the stats processor, every DB here in terms of writes should now only have an eighth of the write throughput it should have before, assuming that all the players writing is split perfectly 12.5% each. So this is sort of, great. And important to note, each of these shards are running their own Patroni set. So each of these have all their replicas, and then the Patroni is updating them in regards. So we've kind of got a lot of DBs right now. What could a possible problem be? Well, you notice everything is still going to this one Kafka ledger. And at this point already, we've got 100,000 players and we are absolutely pumping through this Kafka. It's so much so that we're actually pegging the 10 gigabit wire. So what do? We can have more partitions, more brokers, or we can scale the single cluster horizontally, but that doesn't really work because it doesn't solve the her domain tuning. So firstly, you want to be thinking about everything sort of going to this Kafka. And what did we just do to our DBs? We split it per domain. So let's skip on that for now. We could have a topic per domain. So each domain gets its own Kafka cluster. So that means you have an economy topic cluster, stats topic cluster, cosmetics topic cluster. We could have a regional Kafka plus mirror maker. However, everything right now is single DC, which is impressive because we're literally hosting hundreds of nodes in one database. So we go topic per domain. What does that look like? That looks like now our game fleet is a little smarter in that it knows which Kafka to output to, and this also means that remember how we had multiple processes? Though all those used to just read from one Kafka, now we can actually split it. So we have a processor, our economy processor, for example, can just read from the economy Kafka. And this is actually much nicer than it was before, even though you have to have more things running on the machine. And that's kind of what databases is at its core. It's kind of, you're striking a balance between, obviously, we're going to have the most beautiful stack ever and run 100 pods of various different services, but most things you kind of want to build up to, like what I've described here. Now, I know, you're looking at this, I've had pretty nice animations so far. We all want to see what the full network looks like. And I bet you this is going to lag. Give it a sec. A couple more secs. Hey. So there you go. This is what the Vipixel stack has ended up looking like. Everything was done in Raw.js with the help of my beautiful Claude Opus. And yeah, any questions? Any Qs? Sydney, any QUs? We've got 2 minutes.
So I suppose when you were spinning out the Kafkas as well, when you're talking about the processes, were the processes the pub subs?
What do you mean? Oh, I mean these.
Yeah. Those processes.
So like consumers.
Yeah. Cool.
Yeah. So they're consuming the economy. A consumer knows how to read all the events from the economy Kafka.
Yeah.
And then convert that to a DB effect.
Yeah. Cool. And then so did you end up with essentially like one Kafka that was going almost directly to one processor? Is that sort of how it ended up?
Yeah, that is how it ended up. And that was easier to couple.
Yeah.
That was easier in terms of like when we were setting up, because we're using Kubernetes heavily, in terms of like when we were setting up our Helm charts for what we're deploying together. This is the most obvious like application set.
Yeah.
It was easier. And also, this is sort of simplified. We ended up having like 35 of them.
Yeah.
So we used to have tons, and also that's much easier than 735 Kafkas. Their process was like reading from some's reading from others. This is better like this. And this also ends up leading to really nice code on your game fleet, because your game fleet's actually not doing like any DB connection itself. All we had is like an event system that we had, and then it's completely decoupled from anything database. So we have a team specifically that look at all the events and think, okay, how am I going to make this look on the DB? We can handle indexing, we can etc. And then the game team, all they have to worry about is implementing an interface, and you just have an event object that you're pushing to this Kafka. Yeah.
I have a question. Like, I guess like in terms of like you were like 18 when we did this. Like, what resources would you recommend to look at to I guess develop your knowledge in this?
It's difficult because unlike, for example, I did my bus workshop, you got like buslings, and bustling is really good. In terms of like good DB stuff, there's kind of a lot that's just like community known, like knowing the difference between Patronus or Patroni versus others. Really, you should be able to get a lot by using your Claude with web search. The web search is kind of your favorite tool, Googling things, but it's kind of great that like now you'd have at least some scope of what's possible in your head, because as long as you sort of have a starting point, you can kind of figure out, what's to go next. Do I've got a write problem, a read problem, or am I trying to add redundancy? And then you can kind of move forward from there. And it's 1 p.m.
I have a question.
Yeah,
What says the chat?
Oh, sorry, my bad. I'm on my laptop. I'm not even looking at the chat.
So what do you want? I don't.
Yeah, I didn't mean to ghost you. I'm sorry. Where's answer? Oh my goodness.
Need that new
I need that new Mac, guys.
Yes.
Anna, I hope you're looking. 100 back plays. How you sharded the primary database? Was there a reason why you chose 8, or did you just work with 8 and you can scale? No. At that point, we just kind of chosen 8 because it was kind of a nice number. Like you kind of want to do like 2, 4, 8, 16. It wasn't really anything specific, and we'd run. I believe there was a team that ran the calculations for how many writes would be going. So obviously we have 15,000 writes, and we know that we can handle 5,000 writes. You can kind of just divide it by 8, and you know that you have enough headroom, unless we're going to 3x players, which we didn't end up 3xing players. So it's kind of just, you can kind of just like divide your total writes, and then you're assuming, of course, that your distribution's even across everything, and it should be okay. So I'm pretty sure that's why we picked 8. I don't know, Dylan. Well, thank you for coming to my monthly Lyra stand-up. Appreciate you guys.
Cool. Right.
Oh.
Awesome.
This is so sick.